Hello, today just a short video about a data analysis I've done, and I want to show you how to approach something like that. I analyzed the superheroes dataset. You can download it on Kaggle. Here you have the file for the DC stuff, and you see it's very intense and interesting stuff. If I remember correctly, they used a web scraper to get the data from the DC fan wiki. That's quite a good approach and pretty smart. Here we see all the different stuff we got, and now we need to think about something we want to analyze. Today it's just a simple data analysis, but I could do a machine learning video in the future if you're interested in that. And now let's look at some things we have got here. I think queer representation in comics is an interesting topic, and so I decided to do my analysis on this. Here we see that we have homosexual characters, bisexual characters, and empty, in German leer, means that it's just a normal heterosexual character. And we also have different sexes. We have female characters, genderless characters, male characters, and transgender characters. If I remember correctly, we have only one transgender character, and this one is bad. Nice. Very good representation. So we start with the analysis. First of all, we want to import these two things, Pandas and Plotly. Plotly is express to be precise. We import Pandas as PD, that's industry standard, and we import Plotly as PX. Also a lot of people do that, and that's not that bad, because nobody wants to write Plotly Express all the time. You get insane if you do that. Then this is the first line you need to write most of the time. You load a dataset. Here we did it with the DC dataset, but you could also use the Marvel one. You just need to swap it here. So it's an exercise to the viewer, but it's very, very easy. Then we call a function called preprocessed data. We go to the definition. You could do that with F12. Here we have some function preprocessed GSM, preprocessed sex, and so on. All the columns we need for analysis. You could preprocess the GSM in a lot of ways. Here is the simplest one. If you don't know a lot about Python or about data analysis, and especially about pandas, because we also see a panda specific way to do it. We have here how to preprocess it very easily. We create a list. Because if you only have the data frame at one column, it's a list, logically. And then we move through this list. If it's a float, so if it's none, then we set it to 0. That actually would be a good comment. If you don't know it. If it's a homosexual character, we set it to 1, and if it's a bisexual character, because we don't have any other possibility, we set it to 2. Then we say that the df at GSM is our list. We could print a list, or we could leave this line as it is, and then we return our data frame. There's a simpler solution. Actually, there are two. Simple is the wrong word. They are more complex to write and more complex to read, but I think they are better. If you know a lot about that, if you have done some data analysis, you know them. And I need to zoom out to see the full line, because they are very long. We return a so-called list comprehension. We return, our value, or I in this list, or in our instance it's called x, is 0 if it's an instance of float, else it's 1 if it starts with h, because I didn't want to write homosexual character, and else it's 2 if it starts B, so it's a bisexual character. And for some reason I returned a 3, but there are no other cases, so we could also leave this out, but I don't care. And we do it for each X in our data frame. A different possibility would be to use this panda specific thing. Let's copy this here on the top so that it's more beautiful. So we have our data frame. We apply a function. It's a lambda function, so it's a function without a name and a so-called anonymous function. It's a very important concept if you do a lot of functional programming, and at some point in your program career you are going to do some of it. We return 0 if it's a float, 1 if it starts with H, and 2 if it starts with B, and else 3. That's nearly the same thing, and it's really a question of taste, what you like more. I personally prefer this variant, but I used the other one just to get more familiar with it in the other functions as well. Here we have the good comment. We preprocess also as X, we preprocess the alignment, so if somebody is good, bad, or neutral. We preprocess the ID, we preprocess if he or she is alive, and then we just return the new dataset, and we have all the stuff we want. Then let's move on. We want to create a histogram. Let's have a look at it, how I want it to be. And we see that it failed, and that is very bad. Let's open up a browser, and then it actually should work in my opinion. Yeah, it works. It only didn't work because it didn't have a browser window where you could open it. So here we have a histogram with a very, very beautiful title. And a legend. I think that's very small on a tiny screen, but I can read it to you. If it's 0, we don't have an alignment, 1 is good, 2 is bad, 3 is neutral, and 4 is an ex-criminal. I don't like this ex-criminal stuff because it could also be a good guy after you were a criminal, and so that's not really an alignment, but who cares about my opinion. We see we have slightly more bad characters than good characters. I mean, it makes sense because Batman needs to fight multiple opponents, and there are many villains who only have Batman as their opponent. But the difference is not as high as I imagined it to be. We have 2,789 good characters in the DC universe and 2,880 bad characters. And we also have 516 neutral characters and an incredible amount of ex-criminals, namely 3. Let's look at it for queer characters. Here we see that there are a lot of good queer characters, 43% to be precise, and only 15 bad queer characters. So we see there is something going on here. They are not equal. You could argue if this is good, bad. I think it's a good thing to represent queer characters as something good, as nice people, because we have so much prejudices in the real world, and we need to prevent that or minimize them using fiction. And so it's no use in presenting transgender characters as bad people, because it would also just fuel the hate to them, and I think that's a very bad thing to do. That's why I agree with C that this is not that bad actually. But now you're interested in the technical details. If you are here, you want to see how we create alignment histogram. We got a definition of the function. This comment is useless. We see something interesting here. We have our data frame, and then there is this strange pandas specific thing, and to be honest, I really hate it. So, first of all, That was my mistake at first writing this code. I forgot the parentheses around this expression. I don't know why we need them that much, but Pandas decided that we need them. And normally in Python, you're precisely correct if you think that you would write it like that. But in Pandas there is a wonderful, wonderful thing. We need this thing and or equal sign to show. I mean, it's normal in most other programming languages. Don't get me wrong. But in Python it's not the normal way to do so. And we also need only one AND sign. Normally in Python you would write AND, but no, it doesn't like that. We need this strange sign. And then it's quite easy. We create a Plotly express histogram. We take the queer data from here. Our x-axis is a line. We have the values. Then we want to do some stuff with the layout. We want to set an x-axis title. There we have our legend. We have a y-axis title, and this is just number. And then we print this stuff. We have a title of this stuff. We could format the title even more, but I didn't bother to do so. And then we create the second thing. It's nearly the same, so it's quite boring to show you, but let's move on. Then I wanted to create a little report on queer representation. First of all, we need to get the total number of queer characters. That's quite easy, because we just count the length of the list. If we filter is also a very important function in functional programming. We see in data analysis it's quite useful to know something about that. We take an anonymous function again, and if it fulfills this condition, it's in our list, otherwise go away. And then we add everyone who has a sex that's different from the heteronormative, and then we return the count. We can run this code, and we see we have 85 queer characters. And now let's look at some more interesting code. We want to know how many % of the queer characters are good or are bad. Here we create a general function, so we can say alignment. If alignment is 1, it's good, and if it's 2, it's bad. I hope that was correct. And so we first create a list where only the people with the right alignment are in. We have seen the syntax before, so I won't explain any more about it. And then we use this pandas syntax to filter it even more. And then we just return the length of the new list through the length of the data frame. And we get, let me see, if we execute this code again, or I could just have looked it up over there, we see that we have 41% evil characters. I think we should make it more beautiful. I don't know why I didn't do it in this line. We do it with the round function. We want to round it on 2 commas. Let's see the difference. Now we have this. And then I would multiply it by 100. And I would add a % sign so that everyone knows what we are talking about. Much better. Or if we do it like that, we should actually round to 3 digits. because then we get that it's 41.6%. Then we want to get the percent of queer characters with a special alignment. It's nearly the same code, so it's quite easy. We could move on. Good characters, so this is actually all the same. Maybe we should look at the results to analyze them a little bit more. We see 41% of all characters are evil, but only 31% of the queer characters are evil. I already explained that I think that's actually a good thing. And then we look even further, as 57% of the queer characters, or actually 58% of the queer characters are good. And now we want to look at the next results, and they say that 84% of the queer characters are still alive, compared to only 74% of the normal characters. Or normal is a bad word for that, but you know what I mean. We go to the definition of the function again. I mean, they are all pretty much the same. Can I have a look at this? And if you're interested in more details, just download the code on my GitHub and you can modify it as you like. I think it's an interesting analysis of an interesting dataset, and I hope you learned some little details about Plotly or Pandas. With Plotly Express you could also create a lot of other diagrams, not only histograms, but also box plots and line diagrams and bulk diagrams and everything your heart wants. So I think we are finished for today after a little detail, because I would love to see some of you guys donate to a great charity called Malaria Consortium, or there are many other great charities too, but I think that's one of the best, and it also leads on many lists, like the list on Giver, and it's a very great thing. It only costs around $5,000 to save a life, and I think that's definitely worth it. And so if this tutorial was useful to you, please donate at least some tiny amount, $10 or something like that, to this wonderful charity to help actual people. Bye.